Let's do a thought experiment. I invite you to take a moment and think of all the wonderful ways trackers can support James Bond on his mission. Take a moment and think, what would such a tracker look like? We at Miromico had a very clear vision of such a tracker and challenged us the past year to get as close as possible. The goal of the next 15 minutes is to take you with us on our engineering journey and then, of course, in the end, show you what we came up with. Also, stay tuned. We have some exciting news with you to share at the end. My name is Chiara Koopmans, and next to me is Liliane Paradise.
Thanks, Chiara. Before we start, I'd like to take the moment and introduce Miromico to you. We are a design house located in beautiful Zurich, Switzerland, around 50 engineers working in both the fields of embedded systems and integrated circuit designs. Now we have really shifted our focus towards Internet of Things devices with a particular focus on course LoRaWAN. With over 20 years of expertise in design services, we can be your perfect partner, helping you to realize your business idea, ultimately leading to mass-scale production. Picking it up from there, we also offer manufacturing as a service. That means you'll outsource the whole production process to us, and we'll basically handle everything, including the sourcing, which we all know has been a particularly fun topic over the past few years. Over the last few years, Miromico also has transformed into a product company. We have our own product portfolio consisting of wireless modules, gateways, and of course, end nodes such as trackers. And with that being said, I'd like to hand over to Chiara to elaborate on the why do we actually need such a James Bond tracker.
We might not need to know where exactly in the field our secret agents are located to send by the nearest helicopter, but there certainly are a lot of different use cases where such a James Bond tracker can come in handy. Imagine being able to locate your power tools and heavy machines in just a split second, saving time searching those across your company grounds. Imagine knowing the exact whereabouts of all your vehicles in your fleet and thereby optimizing their routes, again, saving time. You could equip your expensive assets with such a tracker to protect them against theft, saving, again, replacement and insurance costs. You could monitor utilization times to manage the usage more effectively, or you could schedule required maintenance ahead. And thirdly, you could accelerate the search of a missing person. You could locate lone workers on unsupervised areas, and in case of an emergency, know which first responder team is closest to the accident. So thirdly, we could save lives. By now, I might have demonstrated why such a tracker could provide us with key information about assets and people. Now the question is, how do we realize it? Of course, all of these use cases sound great and all require very different features. So our wish list of features has become quite long by now. We want real-time geolocation insights, infinite battery life. We want to maximize the accuracy while minimizing the size. We want panic buttons, buzzers, wireless charging, and ideally, this whole thing should fly. As we're still living on planet Earth, of course, we need to deal with the physical constraints nature gives us. So there are a few trade-offs we need to make. First of all, if we're aiming for a high-accuracy tracker, then we need to integrate a larger antenna for receiving the GPS and Wi-Fi signals, which would then again increase the size of the tracker. And if we're aiming for real-time geolocation tracking, that is going to consume a lot of energy out of the tracker. So that would mean integrating a larger battery pack that we also do not want to do. And if all of this needs to be affordable, really need to think about of what features we want to include and what features we want to throw off the board. So now Lily is going to take you through the 5 crucial steps on how we design such a personal safety and valuable asset tag.
Step 1, of course, decising. At the beginning of this presentation, Chiara invited you all to elaborate on how a James Bond tracker looks to you. We actually did exactly the same experiment at Miromico, and the popular opinion was, well, obviously James Bond would hide it somehow in his weapon, in his gun. Well, Chiara and I agree, if we would be the Bond girls, we would definitely hide it somewhere even smaller, like in our earrings. Of course, we still live on planet Earth, so there's always a difference, a gap between expectation and reality. So while in reality we might not even want to build a tracker that will be embedded into a weapon, also our hero will most likely not be a super agent, but more something like your average worker. So we started to shift our focus towards that use case to build something that's comfortable to be worn on a daily basis. Working it from there, we can start to set the device specifications. Now, we're building a tracker, so everyone will ask, how accurate can you be? Let's be honest, accuracy on a GNSS-based device usually comes with the underlying ground plane size. So something that is realistically to achieve is somewhere below 5 meters, and that will be sufficiently good in order to still efficiently locate people. Needless to say that when we're talking about a people safety tag, that will have to be able to provide a seamless indoor to outdoor transition. Battery lifetime is always a pain point for us designers. Since we're working with a product that will be either worn on or at least close by a human being, we will work with a rechargeable cell. But in reality, maybe we will have a challenging environment where there is no electricity, so the absolute minimum that we'll have to provide is at least 1 month. We're talking about safety, about saving lives. So we have 2 core safety features that we need to specify. On one hand, we have on-demand live tracking, and we'll have to guarantee to receive a fix in less than 2 minutes. On the other hand, we will need an alerting service that has a latency of below 1 meter. And obviously, since we're all human and sometimes not we are lost, but our tag is lost, we should be able to provide a user-friendly tag loss function. As a third step, we're going to decide how does our data get up to the cloud. Now let's have a look at this technology overview comparing data rate versus range. For this specific use case, we really want to maximize the range to provide optimal coverage and, of course, minimize the power consumption. So we'll go with our all-time rockstar sub-gigahertz LoRaWAN. Of course, we don't want to sacrifice on information and rather cut down on redundancy. So what we did is build a smart system that by the means of sensors and some algorithms can detect whether activity has occurred and whether we actually need to acquire a next location fix. But in some use cases, this is still not enough, and we just have a demand for a higher data throughput. Thankfully, technology is advancing, and with the consistent shrinking of the chip sizes, it now has become feasible to incorporate a multi-technology approach into very compact designs. We added Bluetooth Low Energy to our devices to account for short demands of high data rate, such as in the case of firmware update over the air or device configuration. But since Bluetooth still has a very short range, that might still, in some cases, not be enough. And also, with sub-gigahertz LoRa, we'll struggle with logistic problems, having to deploy trackers with different frequency bands in different regions. With our hardware, it is possible to both do sub-gigahertz LoRa and use 2.4 gigahertz LoRa as a fallback for global deployment. Step 4, we're going to be choosing the geolocation technologies, or better said, will really form the heart of our tracker. Let's start with the outdoor use case. Knowing that we have to achieve an accuracy of below 5 meters, we will have to go with a GNSS-based approach. Now, when building a GNSS-based device, we usually struggle with two main pain points. Firstly, it might take a very long time to even acquire a fix, and that will lead to high energy consumption. There we can help ourselves by the means of techniques such as assisted GPS or warm starts, but either we increase the average current consumption in sleep or the frequency band usage. So we had to find a sweet spot in there by the means of an algorithm. The second pain point is usually that either we don't see enough satellite to even solve for a location, or the received signal-to-noise ratio is simply too low. How much we struggle with these pain points usually largely depends on the device orientation, the sensitivity of our radio receiver, and of course, the antenna choice and underlying ground plane design. Now, of course, the device orientation is important because our satellite signals are coming from the sky, so our device will need clear sight to the sky. Regarding the antenna choice, we will want to go with something that has the same right-handed circular polarization as our satellite signal do, such that we can maximize the received signal power. And for that, a really good choice is a ceramic patch antenna. Now, when we move inside, that's where it gets really tricky, because obviously satellite signals simply physically cannot penetrate through the thick walls. At the same time, we do not want our customers having to deploy heavy infrastructure. Now, please tell me, who has Wi-Fi at their home? Raise your hands. I should have probably better asked who doesn't, and that's what we made use of. We're using the RSSI of the nearest access points in order to solve for our location. While this might work very well on a room level, sometimes we have to go further. So again, we'll incorporate a multi-technology approach by adding Bluetooth Low Energy, and we can even add 2.4 gigahertz LoRa-based tracing. Step 5, the PCB design process. And here I want to emphasize that, of course, we cannot treat a whole PCB design process of that complexity in 1 minute. So here we'll really focus on the antenna placement. As you can already see in this illustration up here, we started by placing the ceramic patch antenna right in the middle of the top side of our PCB, because if we move it away from the middle of the symmetrical ground plane, what will happen? We'll have a shifted frequency, which ultimately results in performance losses and accuracy losses. Now, if we have a look at this visualization of the radiation pattern of our antenna, we will see that this antenna has the highest gain pointing towards the zenith, which is, if our device is reasonably oriented, also where our signals are coming from. Yet, we have to place 2 more antennas, the sub-gigahertz LoRaWAN and the 2.4 gigahertz antenna. And of course, we want to do that in a way that it interferes as little as possible with our third antenna. What we did here is to place the antennas on the sides of the PCB, on the bottom side, such that the space in between them is maximized. We are talking about a compact tracker design, but yet we have not placed one of our biggest components, the battery. If we look back to our radiation pattern of the GPS antenna, we see that this antenna barely radiates downwards, so we can make use of this suboptimal property and simply place the batteries on the bottom side of the PCB. And with that little sneak peek on our tracker design journey, I hope that we got everyone a little bit excited about the design that we came up with.
Meet the tracker James Bond wished he had. Our team managed insert all of the specifications Lily mentioned before into one single compact tracker. It weighs only 36 grams and has a diameter of 5 centimeters and can still provide accurate locations both indoors and outdoors. They even managed to fit in an extra loud magnetic buzzer and a high brightness LED to perfectly support our rescue and safety use case. Now, a beautiful tracker alone is of course not enough to go on a James Bond mission. Now, you might remember the exciting announcement I mentioned at the beginning. We are very excited to share with you that we partnered up with Swisscom Broadcast, the national telecommunications provider of Switzerland, to build a company that is specified for tracking solutions. We are very excited to present to you Trami, your new go-to partner for all tracking-related matters. Trami provides highly flexible end-to-end solutions that are perfectly to support companies in protecting their workforce and assets with trackers that fit the smallest requirements. The trackers are integrated into Trami's complete solution, featuring a comprehensive application dashboard and a tightly integrated geolocation engine that computes the coordinates very accurately in the cloud. Now, if you already have an application running, you can directly access the rendered coordinates through our API and integrate them into your very own dashboard. Today, we've been talking about very specific James Bond cases where our James Bond tracker, that now goes by the name Trami Tag S, can be utilized. However, there are a lot of use cases where battery life is way more important than accuracy or size. This is why at Trami, we not only provide one single James Bond tracker, but we offer a whole portfolio to serve diverse use cases. Some of them can be seen behind me on the screen, and for the full portfolio, please visit us at our booth. Now, to close, I would like to share one final thought with you. If we want to decrease the size of this tag even more, we need to either put in even smaller batteries or move the antenna outwards of the enclosure. And this is exactly what we did for our Trami Nomad Extra Small. It is so tiny, it can even track flight routes of a bird. We're using solar cells here to supply the tracker with enough energy to fetch GPS locations outdoors. So currently, this only works outdoors, but as we've heard earlier today, maybe in the future, we're even able to harvest energy from indoor light to supply our trackers with enough battery to do indoor-outdoor tracking. Let's see what the future holds for us. Now, we'd love to hear your opinion about our James Bond trackers and chat about all the specific trackers that are for your use case necessary. And thank you for your interest. Please let us know, do we have the license to build James Bond trackers?
Thank you.